How do you know whether your lipos are any good? How do you know if they're worn out, or if you're going to buy a new lipo, whether it's going to give you a really good result in the racing? Well, lipos have specifications like 90C, 90C or 110C stroke 55C and other figures. And do these tell you that if you buy the highest C, it gives you the best result? Well, you can measure the internal resistance, see if it's true, and you can get internal resistance meters like this, but they're very temperamental. This one is. You have to get the connections dead tight and everything to start at 0 to measure. And it does give you readings on the LRPs, come out the lowest, and these IPs are higher. Does that mean that the LRP will be twice as good as the IP or whatever? Well, I find the internal resistance, the lower it gets, the more difficult it is to tell if the battery is good. Batteries that are worn out start getting very high resistance, it's true, and then they do become sluggish. Some old worn out batteries here, and the resistance hasn't gone up by much, a 1.9 reading, and that you can feel that is sluggish at top speed. And a new one is only 1.5 reading on here, so it's not much of a change. So how can you tell if a lipo is any good? Well, the best way to do it, because you know in a race you want to start off at fast speed, and you don't want your car to slow down as you go along, and sometimes it feels like it's slowing towards the end of the race. Is that the motor overheating, the speeder overheating, the tyres, or is it the lipo voltage dropping? Well, one way you can test this is with a discharge meter. Now I've shown a video on how to make a resistance box cheaply. You buy, say, 5 1 ohm big 1 ohm resistors, 100 watts, and put them in parallel, making 0.2 ohms. Here's a little calculation. So it's 0.2 ohms. 1 ohm, there's 5 of them, divide by 5 gives you 0.2 ohms. And then to work out the current that I draw, say with an 8 volt battery, nominal, so I equals V over R, 8 divided by 0.2 gives you approximately 40 amps. Now, why 40 amps? Well, you can try 20 amps, but things get a bit slow and it takes ages to read. 40 amps is a nice load on a LiPo. It would cause voltage drop if it's got high IR, internal resistance, and will show up quickly on a meter. Now, why do you want to do it quickly? Well, for instance, in a 5-minute race with a blinker, you might draw 2000 milliamps thereabouts. So you can quickly measure on here the voltage of your cell at, say, the start of the race, and then say after a minute, and then after 1000 milliamps and 2000 milliamps. How do you do that? Well, you get a meter like this. It shows, I'll just put it on in a minute, it shows you amps being drawn, the voltage being measured across the 2 wires, which is basically the LiPo, and it'll show you the milliamps going through. So you can actually record the voltage at certain milliamp readings, which would be equivalent to your race, for instance, and you can write them down and compare. Now, a poor battery was going to have a low voltage under load. A good battery will hold up its voltage, but towards the end of the race, say at 2000 milliamps, is it still holding the voltage up? Well, you can tell with this, and then you can go on to 3000 milliamps or even 4000 if you want, and just see what happens. Now, it is important that you check all the batteries the same way, which means you charge them up to 8.4, and you don't leave them all piled up, and check them after, say, half an hour or so, because the voltage will slowly drop off. You charge them up, and then you put them on the meter, you do all your results, and then you take the next one that's charged up and do the same again until you have a comparison table. Now, I've done some tests already to get some readings, and I'll just repeat one for you. I've only done it up to 2 ampere hours. For instance, this LRP, new battery, has a very low internal resistance, but the start voltage, now 7.7 That's on this meter. It reads a bit low. There's a little bit of voltage drop in the wires, but it reads a little bit low to what the battery is, but it doesn't matter. You can compare. That's what you're trying to do. So as long as it always reads the same, you can compare. Now as soon as I put it on, I'll just show you with another battery. You get a reading, and then within a few seconds it drops. Now that is off the line. Within a few seconds that would be the voltage you'll be running at. Then I've recorded it again after a minute, which is about 6,000 milliamps. See what voltage you're at. And 1,000 milliamps, which is about halfway through the race, with a 17.5. 2,000 milliamps, or 2 ampere hour. Another voltage reading. Just making sure the amps is staying the same, so you're getting an accurate comparison. I've also measured the temperature of the cells after 2 ampere hours. Now the lower the better, but I mean, they all seem to be about 27 to 28 degrees. If you had a bad battery, it would definitely heat up. Most people have got a temperature probe, and it's about 20 degrees ambient in here. Most people have got, or you've got one of those little ones for measuring your motor temp. You can do it. A bad battery will heat up, and we'll show you that the internal resistance is high. A perfect battery wouldn't heat at all. It would remain at ambient temperature, but you're unlikely to get one of them. Make sure if you build one of these that you use nice thick wires, good tight connections. A loose connection will give you false readings. And you can buy these sort of meters. Without one of these, it'd be a bit more difficult. You'd have to use a stopwatch and record the voltages at certain times, which you can do that. And you can use another type of voltmeter, digital one, such as, well, this is a clamp meter, but I mean just get a digital meter and connect the probes, plus and minus, and measure the voltage. Get a stopwatch or use your watch or your phone or anything, and as long as you measure all the readings on each cell at exactly the same time, you'll get an accurate reading. Now I'll just show you this this old pack, for instance. I'll just show you what sort of thing you get. This draws only about between 30 and 40 amps, which is enough. You don't want less, it just takes too long. And I built it into this aluminium case, which you can buy fairly cheaply. Put some fans to blast the air in and out. Anyway, I'll just show you, just connect it up, plus and minus. Switch this on, and you can see it starts off 36 amps, 7.11 volts, and the milliamps is going up. Now this pack's not fully charged, I'm just showing it as an example. Now you watch the voltage, and you can take your readings. Hope you can see that alright, yeah, I think so. Take your readings as the race is going on, say at 500 or 600 milliamp hours. Watch the voltage, write it down, take another reading at 1,000. In this case this is ampere hour, so it would be 1, and then at 2, and then so on until you get a chart of your voltage. Now ideally you want the voltage to stay high and not go down at all. That's not going to happen because no LiPo can hold these sort of amps. It's still about 32 amps. No LiPo will hold it up. You'll probably get a little voltage. Always check your wires that they're not hot, especially the connector parts. Any heat on the connector, you've got to sort that out, or it'll give you false readings because it'll heat up. Now this isn't hot at all. Anyway, coming up to say 1 ampere hour, and just always do it exactly the same point. Write it down. This one, for instance, has fallen to it's going to be about 6.9. This meter reads a bit low. The battery's a little bit higher than that. If you here you go, 6.92. If you connect your probes on a digital meter exactly on there, you can get an accurate reading, but it's for comparison, so as long as it's the same, you get a comparative readings. Okay, I'm going to show you one I've just charged up, and then I'll take it all the way through. Okay, here we go, the test. This is a 6000 milliamp hour IP90C. It's not a new one, it's been used. I've tested it once, took 2000 milliamps out, and as you can see, I've just charged it up, put 2000 back in. So that's just finished. You don't want it to hanging around, so try and do it within a few minutes. The quicker the better, to make sure that they're all dead accurate. This one you put in the minus. Now I'm going to just start this off and just do the readings. Here we go. I'm going to turn this on. Okay, it starts off at 7.76, you notice, and drops to 7.70 straight away. So I write that down here. Start at 7.76, drop to 7.70. Then we wait a little while. Now normally they 1 minute, but 1 minute normally comes out at 600 milliamp hours, not 6000, which I said earlier in the video. So when this gets to 600, I'll take another reading. So it's drawing 34 amps. Doesn't take long, as you can see. Probably would have done 3 or 4 laps in 600 milliamps with a 17.5 blinky. It's coming up now. There was 7.57. So write that down there. 7.57. Now 1 ampere hour coming up pretty fast. That's almost halfway through a race with a blinky. It's holding steady at 7.50. See that drop there? Lipos tend to do that. They're like little shelves. They hang on at one point and suddenly drop. 7.44. So we put that in there. 44 at 1 ampere hour. 2 ampere hours coming up next. By the way, while we're just waiting for that, get your next Lipo on charge. Which I'm going to show you this this bigger one, because bigger is definitely better as far as power goes. Unfortunately, the trade-off is weight. So let's just put this on charge. I've got an imbalanced charge. I'm just charging at 10 amps to charge it up. You can check the balance is good. 398, 398. All right. 10 amps, so we'll leave that on while we're doing this, and it's coming up now to 1.5. Oops. As I say, you can discharge the pack all the way through if you want, measuring at 3000 milliamps, which would be good for, say, a blinky, 13.5, and then 4000 milliamps perhaps for a modified or something. Not so important really, but we're testing the quality of the battery, and if your battery is good, or which is the best battery. Now 7.31 it's dropped to. Now I can tell you that getting your battery straight out and use it after charging will give you much better voltage results than leaving it hanging around for a half an hour or something, which definitely drops off the power. So always use your battery instantly after charging if you can. Here we are, coming up to 2, and it's 7.24. So we'll put that down there. Now that was a big drop at 2 ampere hour. Again, it shelved. It was holding a good voltage, and suddenly it just dropped. So we might take it up a little bit further to say 3. Meanwhile, you can check the temperature of the battery. 20, it's reading 29 degrees. I left it on, it's been on a fractionally longer than the other ones, so still about the same. A really cheap battery will get hot, definitely. And we'll do one more reading. As you can see, it's still holding about 31 amps, which means if that had gone funny, you know that there's something going wrong with your discharge, or maybe a connection's heated up or the wire's not good enough. Anyway, it's holding good, and it's coming up to 3. We'll do a reading at 3. You can see that. 2.7. This is getting hot, but it's got the fans on it. I can rest my hand on it, so it's not a problem. Coming up to 3. You have to get it right on the point, because these voltages, as I said, they in shelves sometimes can suddenly drop by a little bit. Is it important? A couple of points, yes it is. Just having a little more 0.1 of a volt, there it goes, it drops quite quickly there to 7.11. So I'll just add an extra one on the end of here, 7.11 at 3 ampere hour. Battery's beginning to warm now, into the 32s. So if you want to heat your battery up, you would continue discharging it all the way, nearly 6,000 if you want to get some heat in it. I'm going to turn it off now, or maybe I'll leave it on while I'm talking. Are these voltages significant? Yes. At the start of a race, if you had 8.4 and someone else had 8.5, only a 0.1, when they take off, they will definitely be quicker for the first lap. It does make a difference. So a difference on here of say 7.4 or 7.3 at towards the end of the race, the 7.4 will definitely be quicker. Or everything else being equal, of course. So coming up to 4 ampere hours, I might as well record that as well, as I'm nearly there. So can you just see that? It's coming up to 4 ampere hours, or 4,000 milliamps. The voltage on this pack. Don't go below 6 volts. You will probably damage your cells if you go below 6. So this is probably just above 7 at the moment, but it's showing it coming up at 7. I'll take it off at 4 ampere hours. I don't think there's any point in discharging all the way to 0 unless you're trying to heat the battery up, of course. Here we come up to 4, and it's 7.05. So I'll just put 705 in there as well. At 4. Okay, I'll disconnect that, just pull that out, and check the battery at 4. It's actually heated up, it's about 35 degrees, and I'll just write that down as well, 35 degrees C, not a lot. So it feels nice. So that's how you're going to do it. Now I've made this chart, and I've got some readings for some new. The LRP new one at 2 ampere hours was holding 7.31. Well, this IP has dropped to 7.24. So towards the end of the race, LRP will be better. Now the big 7,500 milliamp hour one, bigger is better. It can hold a flatter voltage. It starts off at a higher voltage, holds it. At 2 ampere hours, it's still got 744 in it, as opposed to 7.24, so it's going to be quicker. But these weigh 30 grams more. Your car will probably be overweight, slightly off more weight on one side of the car than the other, which a lot of people don't like. So you have to balance up whether you want a heavy lipo or you can do with less voltage. Now, weirdly, I've got a IP6000 used one that's had a lot of use, and it still gives better results than the new one. I tested 2 new ones, and the older one's still better. So batches of lipos, same manufacturer, same spec, also vary. This older one, maybe even a year old, is performing better than the brand new one that I tested. It's not here at the moment. Tested 2 of them actually because I thought the readings were off, but they both tested exactly the same. The last voltage at the 2 ampere hours had dropped. New one, used one. No better than this used one we just recorded, 72. Mine was 71. The big one was there, and the LRP 6000 was the same as my used one. I can do this with all the batteries. In fact, I'll do one just briefly at the end now with one of these old ones to just show you how they drop off, because a lot of people will be using old cells, and it really will show why they can't keep up with the people at the front. By the way, that battery that I just discharged, I just put it on the internal resistance meter, 1.56. Comparing it here, it's about right. It's an IP. New one's a 150. My used one's 1.4. So that was a good batch. The ultimate's 1. LRP's 0.45. So it's just showing that these readings here, the resistance isn't the best way of testing it. Anyway, I'll just do that a couple more quickly for you. I've just charged up this big Ultimate 7.5. Again, I tested it earlier. It's taken about 2,000 milliamps. It's, whoops! Just pulled got these adapters in there. Make sure any adapters or anything you use are dead tight. Don't want any poor connections. So make sure you get it around the right way. Some batteries are plus and minus the opposite way around. And we're going to take the reading at as soon as I switch it on, and then as it drops, I'll plug it in, turn it off. 792 that was at, and now it's dropped to 789. So 792 dropped to 789. Very good figures. As I'll just write that down. That's the ultimate 7.5. I tested it earlier. This is a second test. Do it 600 already. When I tested it earlier, it was 789 and 783. So second attempt, better readings. I've actually found this with lipos that the second time you use them in a racing day, they always seem to go better than the first time. So maybe this is going to show that up. That it's actually not in your head. It's actually real. So coming up to 600 very rapidly and holding excellent voltage. 7.76. Now that is hugely better than anything else I've measured. 7.70 the first time I did it. Let's do it. 7.24. 7.24. And the other one had dropped to 7.05. I'll take it off now. I could keep going, as I said. Measure temperature. 27.28. So good battery. Hasn't heated up any more than 28 degrees C. And the other one had started getting hot. I'll charge this a third time just to see if it makes any difference. Just measuring the resistance after I've just done the test on that 7.5. It's reading about 1.4, which is again not a bad reading. but I measured about 1 originally, but it is temperamental, this thing. You do have to get the connections spot on, but it is an indication that the internal resistance, when it gets low, doesn't really give you the discharge curve. Okay, I'm going to do a third test on this 7.5 just to see if there's any different results. Previously I discharged it to 4 ampere hours, and as you can see it's put about 4 ampere hours back in. It's just finished charging. I've also left it to cool down so that it's not going to give force reading with being warmed up, so it's about ambient temperature now. I'll test it. I won't bore you with the whole thing. I'll put it on, then I'll come back and show you the results. So let's just start it off anyway. Just put that. So whoops, we've just get that connector. Keeps coming out. Just start it off, and then I'll come back to it in a second. Turn that on. So it started off 7.95 and it's dropped to 7.89. So 7.95 dropped to 7.89. Second time we did it, it started 7.92. So it depends how quickly I get the readings. So 7.89. And then I'll come back to it in a minute and show you all the readings. Oops. So I'm just finishing off this test on this third run on this battery. It's just coming up to 4. I've recorded the results so far. I'll show them in a second. Just see what it is at 4,000 milliamps. Just coming up. It's holding 724 at the moment. It's holding 7.24, so just write that down there, and then I've got to turn it off. Do a quick temperature reading. 28, 29. I'll put 29. So these are the results from this ultimate 7.5, seeing whether any improvement from this first, second and third. That was the first run through, the second run through, now the third. Ignoring the instant when I plugged it in, because that's how quickly I can switch it on. It drops. The instant drop is what's important. So the second time round, it was better than the first time. Now the third time, any improvement or better for worse? Well, instant drop 7.89, identical. The 60-second mark 7.76. The 1000 ampere 7.7. The 2 ampere hour 7.44. That's a shelving drop there. It just dropped from 7.5 to 7.44 almost instantly. And then at 3 ampere hour 7.31, and at the end 7.4. 7.24. Temperature's near enough the same. So it's still holding up good, second and third run, so you can run this battery second run, third run, seem to be both excellent. But no drop off. I mean, I could keep going, trying 4th, 5th, 6th, 7th, but it just shows you can use a battery probably all day long, just one battery, and buying the first run, the next ones seem great. I'll just test this old LRP 6000 battery. It rocks a bit, it's a bit swollen, it's been used a lot. Sort of battery that some people might still be persevering with. I'll just test it. I've charged it to 8.4, just come off the tester. I'll test it up and I'll show you the results. I won't bore you with the complete test. Here we are, just coming up to 2 on this old battery. There you are, 7.05 at 2.0, 7.05. I'll take it off. You can measure the temperature too. it's already up to over 30 degrees, showing that it's got high internal resistance. I'll put 33 degrees C, and so that's the old LRP. You may be using something like this, and that's why, look, even though after 1 ampere hour, it's already 7.18, where other good batteries are holding at 744, even 766, 77. Even after 60 seconds, it's 724, which is lower than these batteries at 4,000. So that just goes why you'd be going around much slower than anyone else. So that's the results that you can study if you want, using this simple discharger I've made. You can tell the old battery, terrible voltages, big battery, excellent, and then after that you've got LRPs and others which I haven't got to test. They do vary, but at least you can tell whether your battery is good or bad from these sort of figures. When you measure your own, if you've got your own meter, etc., you'll get different voltage regions, but it's all about comparison at the exact points. Okay, I hope that's interesting for you, and that it helps you race even better.